This is going to be an intro to GitHub, specifically the actual GitHub Git version that a lot of people use, especially for classes like 439, where you're making a bunch of change really quickly and you want to make sure you don't lose anything. So this is what the base GitHub page looks like. So the first thing it always prompts you to do is sign up, but I already have an account, so I'm going to go over here and say sign in instead of making it sign up. So here I'm going to put my username, which is Megan U Texas, then my password, which is what it is, and then now I'm looking at my version of Git. So from here I can see all my repositories, and I can do new repo from here, and here I can give it my repository name. So I'm going to give it example repo, and I can give it a description that's optional. So I'm going to say repo used for tutorial on GitHub for lean in. And here you can either make it public or private. And if you are a UT student with a U.UTexas email account, you can get a couple of free repos for free, and that code, the link to how to do that will be in the description of this video. But you can either make it public or private, and public, anybody can see it, but you choose who can commit, and then private, only you can see it and commit to it unless you add somebody else as a collaborator. And I never initialize with the README, but the READMEs use something called markup, which is a way for you to make them look pretty. So then I'm going to say create repo, and from here it's saying that I can either do a git clone of this repo and then push to it, or I can create a new repository on the command line. I'm going to show you how to do both ways. So the way that I normally do it is I just copy this right here. So copy and then put it over into here, into my command line, so it does everything that I want it to do. So you get status, and we're good. Everything is up to date. And all I have in this Git repo now is my README. So now I want to go back to my incognito screen. So you can also do a git push and pull. So basically the flow is normally what I would do is I would do something like create a new file. So bi test.txt, and then be like, start editing it. So hello world, and there are other tutorials for using the Linux command line and using Vim if you want to go and watch those for what I'm doing here. So I do create a new file, I make sure that it says what I think it says, it does. So now I can do git status, and this is showing what is on my local version. So in Git there are 3 tiers. There is what you have edited yourself locally, there's what you have committed locally, which is just on your machine, and then there's what you've pushed remotely, which is what shows up on GitHub's website. So right now, since test.txt is red, that's telling me that it's on my local editor copy. And so what I can do is I can say git add star will add everything, but you can also add one at a time. So I'm going to say git add test.txt. And now if I run git status again, we'll notice that it's green, and this green means that it is staged to be pushed, it's staged to be committed locally. And the way that I commit locally is I say git commit -m for message, and I give it a, in quotes, I give it a commit message. And so now if I do git status, it says that my origin is ahead of my local copy is ahead of origin master by 1 commit, but I have nothing left to commit. So now everything is in that second tier of locally committed. So now the thing I want to do is called a push, and this push will take it from my local copy, from my local commit to the remote online version. So I want to do git push. And so now if I do a git status, it says there's nothing left to commit, working directory is clean, which means what I have on my local computer matches exactly what's on the remote version. So if we go back to the repo web page, that we had before. So now I'm back here and I can refresh this page and I can look at that I have a README and I have test.txt, which I can look at in the raw bytes here. So I can look at the txt file on here and I can browse through the repo looking at any type of file that I want to. So what I can also do is there's this nice edit button. So I'm going to edit the file and be like, hello back. So what this will do is it edits it on the remote copy. And so now I can commit this change. So update test.txt remotely, blah, 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 for the extra information. Commit directly to master means that I don't want to create any branches. I just want this to go in with all the rest of the normal code. So I'm going to say commit changes. And so now if I go back to the repo, you'll notice the commit message becomes update test.txt remotely. So now I can go back to this, and if I run git status, it says that there's nothing to commit, but that's because it's checking my local copy against what it thinks the remote has. Now, if I want to have those changes that I made on the remote directory on my local copy, I have to run a git pull. And see, it told me that there were two line changes. So if I do cat test.txt, I've noticed that hello back is now on my local copy as well. So now again, the local is up to date with the remote. It just depends on where you do what. And if I had a second person, like a partner that was editing this Git repo on their account, the workflow would be partner A edits and does some changes, commits and pushes, and then partner B pulls and does some changes, and then partner B adds, commits, and pushes. So the way that I work it so that it's easiest for me and so that I don't lose track is I am always very careful to add, commit, and push at least every hour, and especially after I have gotten to a point where I'm like passing more tests, and I try to make my commit messages as healthy as good and like descriptive as possible. I have a friend who, for his Pentos GitHub, literally all of them were just like, fuck it. That was all of his commit messages. And while that's nice, it's like cathartic to type that in, it's not helpful later when you're trying to figure out what level of fucked you were. So be careful with your commit messages. And so to go back to here, if somebody else wanted to deal with my repo, what they would need to do is they would go to my GitHub, and they would look at my repositories and see example repo. And up here at the top, it has clone or download as an option. So what you do is you copy this clone link, and then back in the command line, you do git clone, and then this. So the cloning now created a file called example repo inside of my documents that then I can cd into. And now this is up to date with whatever was currently on the origin master. Also, as I'm here looking at this, I can click on the file and see what the diff was between the most recent commit and what was there before. So this green means that I added these two lines. You can also look, so if I go back to code, we can look at the commits and look at each commit individually. So I can look at the first commit to see what it looked like. And so this gives you a lot of stats about things like what commits did what changes. There's also issue tracking, which can be really nice. I don't use issues because I forget that they exist. But what you can do for each repo is create a list of open issues, and then via the command line, you can say which commits fixed which issues. So if you have a roadmap for your project, you can watch your roadmap be filled in with certain issues and which commits did what. So that later if you look back and you realize you've gone backwards, you know where to go and get things. Sorry, I'm looking at my list to make sure that I'm telling you everything that I'm supposed to be telling you about GitHub. I did the workflow, git status, add, committing, push, git pull. There's also something called a git ignore, list, which is you can tell it to ignore, for instance, all the .out files from all the C code you're compiling, because you don't necessarily need the .output files on your GitHub repo. There's also something called, there are two different concepts of forking and branching. So when you fork, you make a copy of the repository to your GitHub that you can change and edit as you wish. And with forking, you're not really ever expecting to do any pushing back to the original repo. You're just going to be doing a bunch of pulling to keep it up to date so that any changes you make are not reflected. So if, say you have GitHub origin and you have your GitHub fork might pull from origin again later, but your fork will never push back to origin. Whereas with branching, when you create a branch, it's like an experimental version of the repo that you might eventually want to merge back into trunk. So all this terminology is imagining GitHub like it's a tree. So trunk is master, and then branching is anything off of that. So you can have a branch of a branch even, which is a repo that is 2 times removed from the trunk that eventually you might want to merge back in. The issue that people run into the most with GitHub is probably merge conflicts, and that's when 2 separate people have edited the same file in GitHub and are trying to push to trunk at the same time. And the way this normally manifests is before you can push, you always have to pull if somebody else has pushed before you in time. So normally what happens is you'll do a git pull, and then you'll get an alert that you have a merge conflict. And the easiest way to do this is on the lab computers, they have something called merge tool. So after you get this error, it's not even an error. What happens is you get told that you have a merge conflict and to fix it before the next time you push, and GitHub takes your file and inserts like his, her versions of who did what. And so there's a tool called merge tool, and you run it from the command line like git merge tool. And what that'll do is it'll open up this GUI that'll show you what your changes were and what their changes were, and then you can pick and choose which ones to keep. And it may be that you want to save everybody's changes, but it also may be that one version is like horribly outdated and that's what you were trying to fix. And for open source projects, GitHub is like the place to be, right? So if you know of some open source project that you want to do, the first thing you do is learn GitHub, and then go and clone their repo or branch it, and then make what's called a pull request, which I think is named backwards. A pull request is when you ask for your code to be merged onto trunk. I think it should be called a push request, but I was not in that meeting. Anyway, so that is the easiest way to get started with open source projects, is find a GitHub that's doing something really cool, and then notice something really tiny that's an issue, and go and fix that issue, and then do the pull request to ask to be merged to trunk, and then you can do, you can put that on your resume or like talk about the fact that you contribute to this open source site, because one of the cool things that GitHub also does is it tracks your activity. So like this is a graph of my activity on GitHub for the last year. And you can tell there were some days when I did hardly any, like during the summer, and other times like during October where I was very, very active. And there's also on each repository, so like the First Res website repository, I can look at the pull requests or one of these tabs. Oh, graphs. Right. The graphs tab has metrics that are telling you, oh, interesting. Anyway, there are polls maybe. There are graphs somewhere on GitHub that tell you how often you have been doing things, which is really cool. And the graphs may only show up if you have more than one person editing, which I do not on this. 36 commits. Yeah, but I have a lot of commits here, and you can tell I was not good about commit messages because there weren't really issues that I was fixing. I was just slowly making things prettier, so I just called them all updates because I'm lazy. But if you have Downing, he's very, very specific about commits and commit messages and all that jazz. So I hope that this helps. If you have any other questions about GitHub, you can put them in the comments, and I may answer them. I'm not sure exactly how YouTube works with comments and notifications quite yet. But there's some more advanced stuff that I know that I didn't cover, but this tutorial should get you through it should get you through like the 439 that you need for GitHub. So hope it's helpful.